So before I go over problems that involve polar systems, right, as part of pre-calculus, I just want to go over their systems briefly, and they're pretty simple. So when we're talking about polar, we're really talking about r comma theta, right, where r is your radius and theta is that angle. And so you're saying that this corresponds to a certain coordinate point, right, which is x comma y. This x comma y, which we're really familiar to, is known as the rectangular system, right? That's the one we deal with. So if we have points like 3 comma 2, 4 comma 6, right, when we graph them, right, and we form that linear line or that quadratic function, right, those points are obviously x comma y, and those are part of the rectangular system. However, we should be good at converting from polar points to rectangular points, from rectangular equations to polar equations, and all of that. So just to give you a brief overview of what a polar system is all about. So here we know that we can call this angle here theta, right? And we know that this line over here must be x, and then this vertical component here must be y, and obviously this is the radius, right? This is the radius of the circle. Now, it's important for you to understand that this is not necessarily a unit circle, right? If this was a unit circle, well, we already know that cosine of theta, right? Cosine of theta is equal to x, and sine of theta is equal to y. You could say that's a special case of this, because in the unit circle, you know, your radius is 1. Well, if your radius is 1 here, and you multiply both sides by 1, so you're left with cosine theta is equal to x, right? Similarly, if you know that r is 1 and move the r, or multiply both sides by 1, you know that sine theta is equal to y. That's how we define the unit circle, right? When we were memorizing our trigonometric ratios. So you know that any point on the unit circle is cosine theta comma sine theta. However, your circles may not necessarily be unit circles all the time. You may have a circle whose radii, or whose radius, right, is 2 units, 3 units, 5 units, and so therefore it's important for us that when we have this triangle inscribed within this circle, we define our trigonometric function. So we obviously know that cosine of theta is adjacent divided by the hypotenuse, that is x divided by r, sine theta is y divided by r, and tangent theta is y divided by x, right, or opposite divided by your adjacent side. So these are the three obviously trigonometric functions that we look at. Now when we're obviously converting between these forms, it's better to have these 4 formulas memorized, which are obviously derived from this set of equations. So one of them is x is equal to r cosine theta. So know this one. Then also know that y is equal to r times sine theta. Right? So that's the second one. Then you're looking at this, you know that this is a right-angled triangle, obviously, right? Because this is obviously perpendicular to this base over here. So then you can also state that, well, according to the Pythagorean theorem, this must also apply. X squared plus y squared is equal to r squared. So that's another one you want to know. So we have 3 so far. We have x is equal to r cosine theta, y is equal to r sine theta, y is equal to r sine theta, and then we have x squared plus y squared is equal to r squared. And the other one is really just knowing that tangent of theta is equal to y over x. You know, you can further alter this into a form that you really want depending on the question, but know these four different equations, I guess, to really help you solve problems, especially when you're converting between one system to the other. So thanks for watching.